This week, we will begin the last chapter that we will study for Algebra 1B. And we're going to begin this chapter by looking at some functions that are somewhat different from linear and quadratics that we talked about before. We will begin this folder by looking at piecewise functions. In the first semester, we studied how to graph linear functions by using the slope-intercept or using the standard form and plotting the x and the y-intercepts. So we will apply what we learned about linear functions in studying how to graph piecewise functions. Now, a piecewise function is a function that is usually defined or described by two or more equations. And those two equations are normally applied to different parts of the domain of the function. So our first objective for the week is to answer the question, how can you describe a function that is represented by more than one equation? For example, I have a graph here that has, two types of lines. One is a slanted line starting from the origin going to the left upward, while the other is another line with an open circle at x is equal to 0, and then it goes straight following a constant rate of change going to the right. So how are we going to write a function to represent this graph? So first, let's study the two parts of the domain into which the function is divided. So the break happens at x equal to 0. So this graph that extends to the left, that happens when all the values are either equal to 0 or less than, because it's going to the left. So that means the first domain is when x is less than or equal to 0. While the other domain, the one that goes to the right, it doesn't include 0. It doesn't because it's an open circle. And then all the values here, 2, 4, 5, 6, they're greater than 0. So that means the domain to the right is x greater than 0. So now we have to describe the function for each domain. So for the domain x is greater than 0, I mentioned earlier that it's moving at a constant rate. So that means the slope is 0, right? Because it's not moving vertically, but it's just going horizontally. So n is equal to 0. And the y-intercept is positive 2. So if you extend this one, it will cross your y-axis at y is equal to 2. So when you write it down in the form y is equal to mx plus b, it's actually y is equal to 0x plus 2. So if you clean that up a little bit, then that's y equals 2. And that's the same as f of x is equal to 2. Now for the other line, you can imagine that this one extends as well in the fourth quadrant. But just like what we did earlier, when you're trying to find the equation of the line, you need the slope and the y-intercept. So the y-intercept is 0, right? Because that's the only intersection point. It doesn't intersect the x and y axis, except at that point, 0, 0. And then let's find the slope by using this one and here. So that's an exact point. So let's do the rise over run, right? Or delta y over delta x. So we go up one to the left one, up one to the left one. So the slope is 1 over -1 because we went to the left, so it's going to be -1. So when you write it down in y equals mx plus b form, it's going to be m is -1, x, your b is 0, so if you clean that up, you get y is equal to -x. So that means the equation we're going to write here, or expression, is -x. So this is called a piecewise function because you're writing two different equations or expressions representing the graph or function over these two different domains. We're now looking at a different piecewise function or stepwise function, and the corresponding domains are already broken down here. So what we're going to do is write an expression to represent the function or the graph for each domain. So as you can see, like each graph, is represented by a horizontal line or a subset of a horizontal line. If you look at the inequalities for the first domain, for example, this is a closed interval, right? Well, this is an open interval. There's no equal sign underneath the inequality symbol because the graph here has an open circle, while and the pattern is true for all the other domains. So the left hand side is a closed interval while the left hand side is an open interval. So for the first one, from -6 to -3, what is your y-intercept? So, or, what is the expression representing the line? You can think of each portion of your graph as a subset of, the line that has a y-intercept equal to 2. So if this line were extended, that's actually y is equal to -2, right? So that means this blue line here with a closed circle and an open circle on the right hand side can also be represented by the same expression. So for the first domain, the expression is f of x is equal to -2. Now what about from -3 to 0? So is that also a horizontal line? Yes. What is the y value there? It's 0. How about here? Horizontal line, the y-intercept is 2. And for the last one, horizontal line, slope is 0, and the y-intercept is 4. So that means in all of its 4 domains, the expression is just a constant function representing the graph. The next question is, how are you going to evaluate a function if it has 3 different domains? Well, for example, in number 1, f of -8. So in which domain does -8 belong? So -8 is less than -2, right? It's the left of -2. So that means you're going to use the first expression to find the answer. So since -8 is less than -2, then our answer here is 3. Now, how about -2? So -2 is included in the second domain because there's an equal sign here. So that means we're going to plug in or substitute -2 in the expression x plus 2. So -2 plus 2 is 0. F of 0. So f of 0 is included in the second interval again, so plug it in here. So you will get 2. F of 3. F of 3 is still in the second domain. It's between -2 and +5. So 3 plus 2 is 5. F of 5 now is 5 plus 2. And last but not the least, f of 10, now that's greater than 5, so follow the last expression. So that's 4 times x, so the answer is 40. So now that we know how to evaluate, let's try to graph a piecewise function. So the first expression starts at 0 and it extends to the left, right? Because it's x is less than 0. So when x is less than 0, let's create a table of values here. This is x, and then this is x minus 2. So when x is 0, the y value is -2. So this is -2. Okay, now substitute another point included in the first domain. So use any number less than 0, let's say -1. So when x is -1, -1 minus 2 is -3. So when x is -1, go down to -3. Okay, so that's -3, that means, okay, so your line goes that way. For the other part, find x here, and then this is 2x plus 1. So when x is 0, so 2 times 0 plus 1 is 1. So when x is 0, it's equal to 1, but we're not going to put a solid circle because it's not included in the domain, right? So put an open circle instead. And then use the number greater than 1. Let's say 1. When x is 1, 2 times 1 is 2 plus 1, you get 3. So when x is 1, you go 1, 2, 3. So that means your graph goes this way. And you can find other points, you know, maybe one for each domain so you can graph your function accurately.